Okay, Pravina, you are aware about and you are from EE. Okay, great. So, because EEEC, we have both the students. So, we are going to discuss the syllabus of EE in very short, actually. I'm not going to detail in, I'm not going to tell the detailed syllabus. That we will discuss in our first lecture. So, in the electrical branch, we have a vector. Okay, that is the vector calculus. Okay, the vector calculus. Second, we have a coordinate geometry, coordinate system, I should say, coordinate systems. Okay, and I will take del operator, including this coordinate system. And then we have electrostatic, and magnetostatic. The topic which we are going to cover inside that I am not telling, just giving you the broad idea about the syllabus. So electrostatic, magnetostatic, and finally the time varying field. Okay, in the time varying field we have Faraday law, Lenge's law, etc. So this is the overall syllabus of the electrical students, and this is also included in the syllabus of electronics. Okay, so electronics student should also attend all these subtopics, because we will be starting from here only, and not in the detail of vector calculus, because we don't have much detail in we don't require much detailed concept of vector calculus, because here we all are preparing for the exam point of view, because I don't think that you are anyone who want to research in any subject. Yes, you will learn the concept, you will learn how to apply, and you will get a basic concept, but the detail of each and every topic which is not relevant to exam will not be covered. Why? Because we have to cover for the exam, and when you go for detail in every topic, then when you complete the entire syllabus, all the subjects, then you will have very bulk of material to remember, okay, to keep in the memory. So that is not good. If you are preparing for any exam, then your approach should be different to learn the subject and to solve the questions. Okay, so the vector calculus, we will discuss only the part which is required for our further topics or the overall subject. Similarly, the coordinate systems and del operator, and electrostatic and magnetostatic we will definitely cover in detail, because these are the topics which are having weightage in our exam and time varying field. Okay, so the electronics student should also learn these things, even though it is not mentioned in the syllabus directly, but they ask the question directly from these topics, electrostatic and magnetostatic. Okay, so don't think that that's in the syllabus it is not mentioned, so they will not ask, because that is the past experience. That is, I have seen the students they saying that, so these are the topics not mentioned in the syllabus, so we are leaving. And in the previous year also and this year also, one question came from this topic, electrostatic. So they can ask. We cannot say that whether they will ask or not. And yes, they have reduced number of questions in the last 2 years in the subject. So you may think that this subject is not having that much weightage, so I should not cover other topics as well. So now that is the problem with the when the IIT means committee does not take the subject, does not take the question from the any particular subject more. Because if every year they take 8 to 9 questions, then we can be sure, and to learn the each and every topic we will be more interested. But if you don't know, and if you know that where this subject is having less weightage, and you don't know that which topic will come, then it is definitely required to cover all the topics. You will be thinking that electrostatic, magnetostatic will not come because it is not mentioned in the syllabus, so I should cover the remaining part. So if they ask the question and it is having only less weightage, 2-3 questions, and they ask the question from that topic only, So learning the whole subject but leaving one or two topic and the question came from that topic only will means will give you big dent on your overall marks. So never leave any topic until it has not been asked in the past 10, 12 years. If you are seeing that weightage is reduced but the topic is there, so you should prepare each and every topic. I only recommend the students to leave any topic when they IIT and GATE committee have not asked the question from last 10 to 15 years. If they have covered after 2016, then I will ask you to prepare it anyway, whether you don't have much detailed concept, but at least you go through the basic concepts and formulas, because sometimes they can ask the question very basic questions from that topic, and if you leave, you will not even able to solve the basic questions. So apart from this 5 points that I have written for the syllabus of EE, that for all the 5 topics we have to cover for the EC students. And then apart from this, you have to cover the plane wave, so plane wave propagation, waveguide, transmission line, and antenna. So these are the 4 other chapters apart from these 5 chapters in the EE syllabus that we need to cover in the EC. So I will be telling you, okay, when we will start from the vector form, I mean directly from the coordinate geometry, and whatever vector calculus is required, that I will be telling you. Once we will cover up to this point, I will tell you that for EE students do not attend further classes because these topics are not relevant for your exam. Okay, so this is the one thing that you should keep in mind, that we will start from here, and around 10, 12 to 15 hours, that means you can say about 2 to 3 weeks, if we will cover up to this point, time varying field. Okay, so once it will complete time varying field, I will tell you. And if you are not interested to attend further classes like plane wave propagation, this plane wave propagation sometimes asked in the ISRO examination. So if any one of you are appearing in the ISRO this year, if you are passed out and you are appearing for the ISRO, then you can go for this plane wave propagation. Okay, then you can go for this plane wave propagation. And definitely EC students, Jaya, if you are EC students, then you have to attend all the 9 topics I have mentioned here, because in the ISRO examination they ask the question from all these topics as well, and these topics are anyway important for you because you are EC student. I am talking about the EE student. For EC student, this is the entire syllabus. If you want to learn EMFT for any exam in the life, then you have to attend all the 9 chapters. If you want to be specific for the GATE, then this can be preferred over these 5, because there is a less chance that the question will come in the GATE. But in the last 2 years, they are asking the question. So it won't be my recommendation that to leave any topic if you are a EC student, because this is the one-time opportunity you are getting to learn the subject entirely. You have dedicated lectures for this. You have a faculty to ask the question. So you should not miss the chance to learn all the 9 chapters if you are EC student. And if you are EE student and you want to appear in the GATE only, then these 5 chapters which I have written in the left are only important chapters. But if you are appearing for any other government examination like state services or engineering services or ISRO or any other defense type of companies, then you should at least learn plane wave propagation after the 5 chapters, because there are few years in the ISRO examination where 4 to 5 questions have been asked from the plane wave propagation for EE students. So if you can give your time, and if the time is not clashing, then you should go for the plane wave propagation also. Okay. And if suppose the time is clashing with other subjects, then you can watch the recorded lecture when you go for any other exam. Before going to any other exam, you can cover this plane wave propagation. That will be my suggestion. Okay. So there are, all of you have gone through the +2 classes, right? Anyone who is coming directly from the diploma? No? So I'm sure that we all have prepared for JEE, and in the JEE, we prepared the electrostat and magnetostat. So there will be a term which you have prepared in the JEE. These concepts we have to apply here. So it is not about the EE or EC students. So both students have learned through this topic, electrostatic and magnetostat. So basic things are very much similar to what you have learned in your JEE. If you prepared in well in the JEE, then this electrostatic and magnetostatic will be definitely a cakewalk for you. So how many of you are aware about this Coulomb's law? Still, can you answer this? What is Coulomb's law? If I ask you, so definitely I'm sure that it is very easy to remember, and we have gone through in many times in our overall curriculum. So Coulomb's law. What is Coulomb's law? The Coulomb's law states that the force F between 2 point charges Q1 and Q2 is along the line joining between them, directly proportional to the product and inversely proportional to the square of distance. So if there are two charges like this, if there are two charges Q1 and Q2 and distance between them is R, then these 2 point charges, this should be point charges. Point charges, what do you know about the point charges? That is having negligible. They are stationary, and we can denote it in the form of a point. The charge is concentrated in very small area, so we don't consider its area. It is a point, so area is, you can say, the 0. Okay, and Q1 and Q2, this Q1 will exert a force on Q2 and Q2 will exert a force on Q1. We are aware that if the two charges are of same polarity, then they repel each other, and if the two charges are of opposite polarity, then they attract each other. That means like charges repel each other and unlike charges attract each other. So if we want to calculate the force exerted between these 2 point charges, then this Q1 will repel, Q1 will repel this Q2 in this side, and then Q2 will repel Q1 in this side. So force F from 1 to 2. Along the line joining, it is written, right? So you have to join the line from the charge because of which you want to calculate the force, due to which you want to calculate the force. So we want to calculate the force on 2 for Q1. Means force is exerting Q1 is exerting a force on Q2. So this is represented as F12. Okay. Now it is directly proportional to, according to the statement, along the line joining, the direction of the force should be there. So we are saying that the direction of the force is this. Because of Q1 you are calculating, so I am joining the line from Q1 to Q2 because I want to calculate the force on 2. So because the line is joined from 1 to 2, I have written F12. It is directly proportional to product of charges, that is Q1 and Q2. And inversely proportional to and inversely proportional to square of distance. Okay, so here we have written the capital R. So in the diagram also I will mention capital R. So this is R square. So this is the magnitude that we write in this way. The force is directly proportional to product of charge and inversely proportional to square of distance. This is the very first topic of your electrostat. Now, the direction also you can tell if it is along the line. That means you can easily say that they will repel, they will attract, but you are not able to tell in which direction, whether it is X direction, Y direction, or Z direction, because there is no coordinate given to you. Hence, we will right now we have written in the form of magnitude. Now, there is a proportionality constant which is 1 upon 4 pi epsilon naught. Then Q1, Q2 upon R square. This is the proportionality constant, which is also represented as K. This proportionality constant is represented as K, which is 4 pi epsilon naught. The value of this K is given by 9 into 10 to the power 9. Okay, or it is also written as, okay, 9 into 10 to the power 9 only. The unit is meter per farad, which is the unit of capacitor. Now, there is another term which we are getting here, which is epsilon naught, which is the permittivity of free space. The permittivity of free space, and it is 4 pi into 10 to the power minus 7. Okay, 4 pi into 10 to the power minus 7 farad per meter. Okay, so epsilon naught is equal to 4 pi into 10 to the power minus 7 farad per meter. This is overall value. Now we have calculated the magnitude, but we don't know exactly the direction. And from the basics of the vector, we know that to represent the direction of force, we use the unit vector. Unit vector tells us the direction of force. So we will write the vector form of Coulomb's law so that we will be able to determine the direction of the force. And the charges are here static in nature. That means they will be in rest. The charges is not moving. Anything which you want to ask in this particular page? Anything? Anything? Yes, yes. Very good. That is what I want to tell, that awareness in the class. Okay. Absolutely correct, Ashwini. Yes. So 8.854 or 10 to the power minus 9 divided by 36 pi farad per meter. Absolutely correct. So I wanted to see that how many of you are going to pick this particular point, that epsilon naught value I had written was incorrect. Okay. Now, because you don't have any question in this particular page, so let's move further. Let's understand the vector form. So vector form of Coulomb's law. So what is the vector form? The vector form will give us the direction. Now for this vector form we are considering these 2 point charges Q1 and Q2. Okay. Do you know about the position vectors? Do you know about the position vectors? The position vectors are nothing but when you calculate the distance from origin. Okay, so I'm right now, because it is a demo lecture, so I'm assuming that something you know. If you don't know, there is no issue. In the actual lectures, I will tell these position vectors and all in detail in itself. So x1, y1, z1 is the coordinate, and x2, y2, and z2 are the other coordinates. Now, if I say the position vectors, that means the vector r1. So the value of vector r1 is nothing but x1 into I cap and y1 into j cap and z1 into k cap. Because x1 minus 0, the origin is 0, 0, 0. So basically, we are calculating the distance from origin. So x1 minus 0, and the direction will be in the x direction. So x direction is represented by I cap, y direction is represented by j cap, and z direction is represented by k cap. So this will be the vector r1. And vector r2 will be x2 I cap, y2 j cap, and z2 k cap. This is the r1 and r2 vector. Now when we want to calculate the force on the charge 2 due to 1, then we said that it is along the line joining. If you want to calculate the charge on 2, okay, charge on 2 due to 1, so I will join the line from 1 to 2. So I will join the line from 1 to 2 like this. So you are joining the line from 1 to 2. So whether it is a positive or negative, you should always write the direction in this form where you are joining the line. Okay, when we were studying in the JEE, when we were preparing for JEE, we used to have the formula always like this, and we used to calculate the direction according to the polarity between the charges. If they are like charges, then they will repel, and they are unlike charges, then they will attract. So this is true. This is still true, but we will be telling the force, direction of the force according to the vector form. When you write in the vector form, automatically it will give you the direction, whether it is according to the plus plus or according to the unlike charges. So because you want to calculate the force on the charge Q2 due to Q1, I will join the line from 1 to 2, and I will give the name as 1 to 2, force from 1 to 2. So when we want to calculate the distance between these two charges Q1 and Q2, then we call it as a displacement vector, because we are moving from 1 to 2. So this is the displacement vector. Okay, this is the displacement vector because you are displacing from the location of charge 1 to location of charge 2, 1 to 2, R1. Okay. Now, how do you write this R12, which is known as displacement vector? So displacement vector is nothing but the displacement from one point to another. So basically, it is final point minus initial point. Final point minus initial point. So what is the final point? It is x2, y2, z2. So we can write x2. And what is the initial point? X1. So when I am subtracting, I have to subtract according to the coordinates. So x2 will be subtracted, x2 and x1 will be together. Then y1 is subtracted from y2. Then z1 is subtracted from z2. And this is known as displacement vector. So when we want to write the force, okay, when we want to write the force, then what will be the value of force? Because we want to tell with the direction, so it, according to what we know, it should be k1 q2 upon r square. So what is the r square? That is nothing but the distance between them. So we need a distance. So this is in the vector form. If you take the magnitude of this vector, you will get the distance between them, which is represented as r12, and it is nothing but x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, so this is the actual distance between them. Now we know the charges, we know the distance, so everything we know. Now we can write the force. So force on charge Q2 due to Q1 is F12. Now it is in the vector form. Force is a vector quantity. It has direction. So F12 equal to K into the product of charges. So it is Q1, Q2 divided by R12 square. This is the distance between them. Now we have to tell the direction. So direction is from 1 to 2. So basically when you are moving from 1 to 2, the direction of force is also along with that. So I can write that it is nothing but unit vector in the direction of R12. It is the unit vector in the direction of R12, because when I am moving from 1 to 2, the force is also in the direction from 1 to 2. So how do you represent this vector direction? We can write the direction of R12. So what is the direction of R12? The direction of R12 is unit vector. The direction of R12 is unit vector of R12. So unit vector of R12 is A cap R12. So this is K Q1 Q2 upon R12 square into unit vector. How do we write the unit vector? Unit vector is nothing but vector divided by its magnitude. Vector divided by its magnitude. So magnitude we have calculated in the above expression, which is written in the black. So F12 is K Q1 Q2 upon R12 whole cube, and the direction is R12. So this is the vector form. This is the vector form of your Coulomb's law. Okay, and where R12 we have calculated, we can substitute it. R12 vector we have calculated, R12 magnitude we have calculated. All these values you can substitute and calculate its numerical value. Is it clear? Anyone having any doubt in this? So the F12 means force exerted on the charge Q2 due to Q1 will be given by this expression. The force on 2 due to Q1 will be given by this particular expression. So vice versa you can do, only the sign will change. That is, when you can calculate the force due to 2 on 1, force on charge Q1 due to Q2, it will be F21, because the direction of the line joining will reverse. Rest of the things will be same. The distance between the charge is same. The product between the charge is same. So what it will change? Only the direction. And how do you represent the direction? That is, with respect to F12, the direction of F21 is reverse. So you can just put the minus sign. That means you can say F12 minus of F12 is F21. Minus of F12 is F21. Minus of F12 is F21. The rest of the things will remain same. Only the direction will change. Okay. So this is about the Coulomb's law and its vector form. Coulomb's law also follows the superposition law. Superposition theorem or superposition law says that if there are n number of charges, suppose there are n number of charges like 1, 2, 3, like this we have n number of charges. This is suppose Q1, this is suppose Q2, this is suppose Q3, this is suppose Qn. And if you want to calculate the force exerted on P, then it is nothing but the force, due to 1, the force due to 2, the force due to 3, and so on up to force due to n. So this is F1, this is F2, this is F3, this is Fn. So you can write the force is the vector sum of all the forces, F1, F2, and F3, and so on up to Fn. Okay, this is just the superposition theorem. I'm not going in the detail because the derivation type, or you can say that how we will write the F1, F2, F3 value. These things we will cover in our detailed classes. Okay, the direction is along the line joining, but what will be the magnitude of the force? How we calculate the force value in the vector form? All these things we can write for these F1, F2, F3 according to this particular law which we have discussed for the coulombs. I mean for the 2-point charges. So these things we can apply here also. This is another charge, let us say capital Q, and in this particular charge capital Q we want to calculate the force. So because if you want to apply the Coulomb's law, then there must be 2 charges. So Q1 and Q, there are 2 charges. You can have the force between them. This is suppose the distance R1, this is suppose the distance R2, and this is R3. So we can write these forces value based on these expressions that we have written here. Okay. So this is the thing. Now, anything which you want to ask about this Coulomb's law? Their point charges should be static. Okay, it should be stationary. It is an electrostatic part, so charge will not be moving. And basic laws we have gone through. And what we can talk about here in the Coulomb's law, that where it should be 0, where should be force is 0, where should be the maximum value. Okay, these things also we can calculate, and you have already gone through that particular part. When suppose there are 2-point charges and you want to write here, suppose this is the 2-point charges Q1 and Q2. So where should we put the another charge, let us say capital Q, such that the force becomes 0? So these things we can calculate. The force is 0 at this particular point. How the force can be 0? So first of all, what should be the polarity to make the force 0 on this point? Because this is also positive, this is also positive. Q1 and Q2 are positive. So you have gone through this type of question in your JEE and also in your engineering, that where we have to locate this particular point charge Q such that the system is in equilibrium or the force on this particular charge Q is 0. So because this is positive, this is positive. So if you will keep the charge plus Q, then what will happen? The Q1 will have the force on Q in this direction. Let us say this is F1, and Q2 will exert a force on plus Q towards left, so F2. So this particular charge Q, which is placed at point P, can be in equilibrium because both the forces are opposite. So if we make F1 equal to F2, then the charge plus Q will be in equilibrium. We are not saying that the system is in equilibrium, but we are talking about this particular charge. The system is not in equilibrium. Now you will say, sir, how the system is not in equilibrium? System is in equilibrium means all the three charges should not be changing its position. All the three charges should not be changing its position. So if the charge Q2 is positive and the other two charges are also positive, then both will repel this particular charge Q2. Both will repel. And if both will repel, then the overall force on this charge Q2 will be towards right, and hence this charge will start moving. Okay, similarly for the charge Q1, this Q1 will get force, this charge Q1 will get force due to plus Q and plus Q2 towards left, because both are positive, so both will repel, and hence this charge Q1 will also start moving towards left. So that's why we are saying that the system is not in equilibrium. System is not in equilibrium, but the plus Q charge, we can say that it is equilibrium because the force applied on that plus Q charge is zero, or we can say that it is equal and opposite. So in such type of question, we look for the overall equilibrium, that means the equilibrium of the system. So ideally we should keep the negative charge here. Okay, if I keep the negative charge, then what will happen? Then the force exerted on this minus Q will be attractive force, because this is plus Q, this is minus Q. Okay, this is plus Q and other is minus capital Q. So Q1 and minus Q. So definitely they will attract each other. So this charge Q1 will exert a force on minus Q towards left, which is F1, because this plus Q is attracting minus Q. Similarly, this Q2 will also attract this minus Q, hence the force will be attractive, and that is towards right. Now also these two forces are equal and opposite, hence the charge plus Q will be in equilibrium, no doubt about it. So in the previous discussion and this discussion, both the discussion have the force on point P in equal and opposite direction, so it is in equilibrium. But now let's see whether the overall system is in equilibrium or not. So in the plus Q2 charge, the force is due to Q1. The force exerted by Q1 is towards right because it is repulsive. Fine. Now this minus Q and this is plus Q. So this is attractive force. This minus Q will attract this Q2. So this is attractive force. Now you can see that in this plus Q2 charge, the forces are opposite in nature. So opposite in nature means they can be in equilibrium. And when it will be in equilibrium, that is the particular case that we have to apply and calculate the value. So I am just telling you the concept. The mathematical calculation we will do in the detailed syllabus. So here you can see that this plus Q2 is having the two forces. Because of the minus Q and the plus Q will repel, minus Q will attract. Hence this plus Q2 charge can be in equilibrium. Similarly, this Q1 is attracted by minus Q, so it will be this force, and this Q1 will be repelled by plus Q2, so this is plus force. So again, in the Q1 force also, in the Q1 charge also, the force are repulsive in nature. Hence, this can also be in equilibrium. So now you can see that all the three charges have the forces in opposite direction. All the three charges have the force in opposite direction. And if the force is in opposite direction, then they can be in equilibrium. Okay, they can be in equilibrium. They will be equilibrium or not, that depends upon where you are keeping the charge minus Q. At which distance you are keeping the charge minus Q, it depends upon that. But we can see that all the three charges are having the forces in the opposite direction. Hence, we can say that this overall system can be in equilibrium. Right? Anyone having any doubt? Okay. So I think everyone is clear with what we have discussed. So guys, for any query, you can contact in this number. We will be meeting soon in the Wednesday class. So our classes will be scheduled on Wednesday and Saturday and Sunday. These 3 days we will be having the classes. The overall syllabus for this subject will be around 50 hours. Okay, the overall subject duration will be 50, and for the double E students it will be 15 to 16 hours, and the remaining portion will be for EC student. Okay. So suppose you have any query, just please ask me because we are going to end the session. Pravina, there is a separate group, WhatsApp group is there, and you can contact me directly from that WhatsApp group. You can post your doubt in the group itself, or if you don't want to put there, you can you can send me directly. You will get my number from that group. So according to the previous experience, there is no issue of doubt clearance. So you can clear the doubt at any time, no issue. Yes, Shrikar, the classes will be every day. These 3 days EMFT will be there, and the remaining days there will be other subject. Okay, means that there will be two subjects in parallel. So according to the availability of the faculties, these 3 days. Okay, Pravina, so you finished your BTech in 97. So any means you are preparing for PhD. You are giving this exam for PhD or what? Praveen, no issue with that. That if you have uh, doubt, then you can ask in the group. No issue. We are there, and we are always there to help you out. So okay. So this Wednesday, Saturday, 3 days we have class, and remaining 3 days you will have other subject. The two subjects will run in parallel. No, okay. So Shrikar, your doubt is also clear. Definitely, except Monday, if the sir has said, then you will have 6 days in a week, and one day you will have off. And the Sunday also we have in the first half only. So Sunday whole day after 1 o'clock, means after lunch, you can say you will get complete time to revise the things or uh, to go through the formulas and to practice your questions. You can utilize them. Okay, the Sunday morning only we have a class. 1 day offline. No, 1 day offline is off. I said off. Means there will be no class on Monday, na? You said. Okay, so thank you guys. Thank you all of you. Thank you for having patience and listening to me. And let's meet on the actual class of the subject. This was a basic lecture, demo lecture to make you understand how we are going to go through this overall syllabus and to make you understand that what will be the teaching style and what are the how much detail we can go in the any topic and what is the requirement. Okay, thank you guys again. Good night.